This is a podcast of Scripps Institution of Oceanography at UC San Diego. To learn more about how you can support Scripps, visit us online at scripps.ucsd.edu. The summer vacation getaway to a sandy beach is an annual rite of passage for millions. Beach tourism has become big business in recent decades as tourists flock to sandy beaches and spend their vacation dollars on restaurants, hotels, and regional businesses. Scripps Institution of Oceanography at UC San Diego scientists Richard Seymour and Robert Guza have been studying beaches as a component of complex shoreline systems that are constantly in motion. Beaches grow with input of sand from rivers and cliffs, but are eroded by ocean waves. Seymour and Guza's research is building upon a foundation of coastal science pioneered at Scripps through the Coastal Data Information Program, or CDIP, a network of buoys that relays vital information about wave movements and other coastal activities. Today, CDIP data is not only used by scientists, but has a devoted legion of users ranging from harbor masters to surfers, who access it daily through the internet. Through CDIP and the Southern California Beach Processes Study, Seymour and Guza are forging new insights into the dynamics of today's coastal processes to better understand what the beach of the future may look like.
The CDIP is a very broad program that encompasses measuring waves. Let's start with the real-time information, and that's most important to people who are going to have to be in the ocean or be subjected to the ocean, and they want to know ahead of time what's in store for them. Now, a large group of them, of course, is surfers, but boaters, ship operators, people doing construction in the ocean. So there's a wide variety of people who use the real-time information or use our predictions of what the wave conditions are going to be like a day from now, or 2 days from now, or 3 days from now. But certainly, it does a lot of things besides science now on safety of construction operations. Picking the right day to do whatever it is you want to do in order to have the right conditions is extremely important. We find that every day our customers, if you will, are finding new ways to use our information.
CDIP laid the groundwork for a variety of advancements in understanding wave processes, and now Seymour and Guza are probing more deeply into other areas of the coastal region, including the movement of beach sand. In doing so, the researchers are finding out that not all beaches are the same.
One of the things that we're learning by monitoring sand levels on different beaches is that there are some particular beaches that have odd behavior relative to the other beaches. For example, they don't seem to erode much in storms. We're not sure why, but we've found a beach or two like that in Southern California, and if we can understand why that beach is not eroding in storm waves, there's something about it. And that could perhaps be a valuable thing to know, because maybe it could be mimicked and we could stabilize some of our eroding beaches.
New scientific tools backed by GPS technology are pushing investigations of sand processes to new levels through highly precise ground, sea, and air measurements.
The key tool is GPS, Global Positioning System. This is not the GPS that might be in your automobile that tells you within maybe 50 feet where you are. That's plenty fine for driving on the highway, but our GPS will tell us within about a few inches where we are in the horizontal and within a few inches in the vertical. We can drive an ATV, that's what you just saw before, but we have other tools that use GPS. We have a jet ski with a GPS on it and a depth sounder. So we drive it around and we measure the location of the sand underneath the water. We also do twice a year with the University of Texas what are called LiDAR surveys. Basically, a GPS on an airplane flashes a range-finding LiDAR. I won't bother you with the technology, but it surveys the sand level on the beach as the plane flies overhead. The airborne LiDAR is an exceptionally valuable tool because you can survey 100 miles of beach in one day.
Guza's research is helping guide plans for how the beach of the future may respond to rising sea levels. Currently, estimates from climate scientists have the oceans rising anywhere between 7 inches and a full yard by the end of the century, with potentially devastating consequences.
There are scenarios where the climate is going to change in the next 100 years or so, and there might be more storms. Well, the kind of question we can address with our model and our science is, if there were a series of very large El Nino storms, for example, how might the beach respond? And just at this particular beach, for example, Torrey Pines, a valid question is, the ocean is right now only 25 feet or so from the highway. Is that 25 feet going to turn to 0 feet so that the waves are washing up on the coast highway? That's not improbable. It already happens, rarely, but it happens now with big storms and high waves. Well, what's going to happen if they happen much more frequently? How much erosion is there going to be? By understanding how beaches work now, we can better make forecasts of how the beach will respond to future climate changes. We're not sure what they will be, but we have some idea. We're trying to get kind of a handle on what might happen in order to better plan for it.
This has been a presentation of Scripps Institution of Oceanography at UC San Diego.